Hello, my name is Felix Lieb. I would like to give a talk at TEDx Redmond 2014 about models and science. I've always had a particular interest for philosophy and science. In the talk, I'd like to discuss some of the fundamental principles of scientific models to understand how we make conclusions about the universe based on our observations. How do we know what we perceive as true? How do we know that we're not just like this poor little rover being misled by forces we do not yet see? Today I'll introduce just some of the basic concepts to comprehend where all of our scientific knowledge comes from. The two most common kinds of reasoning are inductive reasoning and deductive reasoning. Deductive reasoning allows us to prove a rule for any case that may arise, for example, the Pythagorean theorem. By proving the theorem, we can conclude that there is no way to draw a right triangle that contradicts this theorem. Inductive reasoning, on the other hand, is much more uncertain. There, we look at individual cases to make a conclusion. For example, I might conclude that all swans are white because every swan I've ever seen was white. However, tomorrow I may observe a swan that contradicts my conclusion, like a black swan. My conclusion from before that all swans are white is no longer accurate because I found a case, the black swan, that contradicts this conclusion. Which of these methods can we use to make a conclusion about the world around us? Obviously, we'd like to use deductive reasoning because that way we can prove our rules absolutely. Unfortunately, our conclusions depend on our observations, like the swans. Therefore, inductive reasoning is really the best we can do. In order to make conclusions about the world around us, we also have to make sure the conclusions we make are logical. In logic, an argument is defined as a series of premises followed by a conclusion. So this example of an argument would read as follows: if A, then B, A, therefore B, because the arrow means if then. This form of an argument is valid because the conclusion follows from the premises. There's no way to make all the premises true without also making the conclusion true. However, for an argument to be valid is not enough. For example, since we can substitute any true or false statement for A and B, we might substitute the moon is made of cheese for A and it is December for B. Then the argument would read as follows: if the moon is made of cheese, then it is December. The moon is made of cheese, therefore it is December. While this is a valid argument and it's completely logical, it's obviously false. So scientists really look for more than just valid arguments. They look for sound arguments, which are arguments that are both valid and actually true. An example of a sound argument is right here. If we substitute A for it is the year 2014, and it is not a leap year for B, then this argument would be both valid and sound. The way we make conclusions about the world around us is to construct models. With observations and measurements, we collect data. Then we create mathematical or logical formulas to compute that data. The more sophisticated our models get, the more data we have to collect, and the more complex our formulas will be. Without the data, our mathematical formulas would simply be an abstract series of mathematical operations and values that don't have a real-world meaning. But without a formula to plug in our data, we could not compute a final conclusion. Incidentally, this chart helped prove the existence of the Higgs boson. And this ridiculously long equation is part of the Standard Model, which helps explain virtually all interactions between elementary particles, like the Higgs boson. This data, together with the mathematical formulas, finally allows us to come to a conclusion. In this case, a better understanding of elementary particles which make up the universe. These conclusions can have a profound effect on us and our understanding of the universe. We can put these fascinating models to use and develop advanced technologies, or we can philosophize about the amazing implications of the conclusions we make. In this case, the Standard Model helps us understand what the universe is fundamentally made of and how these particles interact to make up everything we observe today. This example of a model is from the breathtaking field of particle physics. But this process, collecting data, plugging in the data into mathematical and logical formulas to come to a conclusion, is used in all sciences, from particle physics to economics or anthropology. The way anyone can make a conclusion about something that happens in the real world is to collect data, use mathematical formulas to finally come to a conclusion. These are just some of the few things that I'd like to discuss in the actual TED Talk. I'd like to go into much more detail about how we make observations, and how we turn these observations into models, and what this actually means for our society and our species. For years, I've been an avid viewer of TED Talks given around the world. I've attended TEDx Redmond 2012 and 2013, and I'm definitely not going to miss this year's event. I hope you'll consider me in choosing which of the many ideas to present and spread this year. If you have any questions or comments, please email me. Hope to see you all at TEDx Redmond 2014.